Okay, so let's go ahead and tackle number 9 in problem set 2 with the coffee cup calorimeter. So for the first question, all we're really going to try to do here is we're going to try to figure out how much heat the copper block lost. So we know that for Q, for the copper, it's going to be the mass of the copper, which is right here, 121.0 grams, times its specific heat, which is pretty low here, 0.385 joules per gram degrees Celsius. And then the change in temperature here is going to be the initial temperature, which was 100.4, subtracted from the final temperature. So 30.1 degrees Celsius minus 100.4 degrees Celsius. So T final minus T initial. So when that's all said and done, we end up with 3,274.9 joules of heat released. Now I'm going to make this negative because this is exothermic for the with respect to the copper. So in the next problem, they're asking us how much heat is gained by the water, and they say the specific heat of the water is 4.18 joules per grams degrees Celsius, or Kelvin, degrees Celsius, Kelvin, it doesn't really matter, I guess. And so for this one, they actually gave you information from about the water. They're telling you that the water is going to reach a temperature of 30.1 degrees Celsius, and we've got 150 grams of water. And they also told you that the original temperature is 25.1. So for right now, we're going to ignore the heat that was given off by the copper, because this problem is just basically saying how much heat was gained by the water. And we're going to see in question C that they're not exactly the same. So the heat gained by the water, we're going to use the same method. It's going to be the mass of the water, which is 150.0 grams. Specific heat of the water is, I use 4.184 joules per gram degrees Celsius. And then my change in temperature is going to be the final, which is 30.1 degrees Celsius, the same temperature as the final for copper, minus the initial, which is 25.1 degrees Celsius. Now I get the heat gained by the water as being 3,138 joules. And that's positive because the water is accepting that heat. Now I'm going to write endothermic. You'll notice that these numbers are not the same. We actually have more energy given off by the copper than what was taken in by the water, but that's because some heat was lost. So at this point, that's all we really needed to do is calculate that part. Now watch your units on this, and also watch significant digits. When I subtract here and I look at these significant digits, this ends up being my last significant digit. So I have 3 for the heat of copper, and then I also have when I subtract 30.1 and 25.1, I only get 2 significant digits here. So this ends up being my last significant digit. I'm going to keep them all for now. So now question C, let's see if I can get down there. C and D, it says that these answers are different, which we know, we can see that. The difference between your answers for A and B is due to heat loss through the styrofoam cups, all right? So it's not a perfect system. Now it says the heat necessary to raise the temperature of the inner walls of the apparatus. The heat capacity of the calorimeter is the amount of heat necessary to raise the temperature of the apparatus by 1 Kelvin or 1 degree Celsius. We need to calculate the heat capacity, but here's the important part. These are the units that we want. So basically, any heat that wasn't taken in by the water was lost to the calorimeter. So the heat that was lost to the calorimeter is equal to the 3,274.9 joules that was given off by the metal minus 3,138 joules, which was taken in by the water. So the difference there is approximately, let's see, 137 joules of heat lost to the calorimeter. Boy, this handwriting is horrible, but there we go. So 137 joules of heat was lost to the calorimeter, or in other words, gained by the calorimeter. So in order to find the change in temperature, we know that the change in the temperature of the calorimeter is going to be the same as it was really for water. We're going to have its final temperature, 30.1 degrees Celsius, and its original temperature, the walls anyway, 25.1 degrees Celsius, because the water was in contact with it. And so the change in temperature ends up being 5 degrees Celsius, or 5K, doesn't matter, either way. So heat capacity, if we look at the units for this, the heat capacity, we just want joules over K. So now we have it. The heat that was gained, 137 joules, divided by the change in temperature, which is 5K, gives us an answer of, let's see, 27.4 joules K. Now, the significant digits here are a little tricky, and we should end up really with one significant digit, and that's really because for the heat, that 137, the one's the only significant digit there. And go back and take a look at that and you'll see. So I went ahead and I rounded that to about 30 joules Kelvin for the heat capacity of the calorimeter. Now this last question I took literally as in all the heat lost by the copper block got absorbed by the water in the calorimeter, so nothing was lost. So I'm going to go back. If I take a look at the heat that was given away by the copper, it was 3,275 joules of heat given away. Now, I'm going to kind of pay attention to significant digits here again, and I'm going to set that equal to the heat gained by the water. So in other words, since the water's gaining heat, I'm going to leave this number positive, okay? Since it was exothermic for copper, it's endothermic for the water. So I'm going to leave Q positive and set that equal to the 150.0 grams of water. Specific heat of water is 4.184 joules per gram degrees Celsius. And oops, my change in temperature is what I'm going to calculate. So when I calculate delta T for the water, if all of this energy was absorbed by the water, I end up getting 5.218 degrees Celsius. And if I add that to the initial temperature, which was 25.1 degrees Celsius, I end up with a final temperature of 30.3 degrees Celsius, and that is my T final. Okay, and I knew to add it because I knew the temperature of the water was going up, and so I knew I had to add that 5.218 degrees Celsius to the temperature that we were initially at. So that's what the final temperature would be. Now I know that this problem kind of creates a little bit of an issue because you would think the final temperature of the metal would be different as well, but taking this question literally as all the heat lost by the copper block absorbed by the water, that's what they're asking you to do here. So it's kind of just taking that question for what it is. Hopefully that helped, and if you have any more questions, just come see me.